add the WhatsApp group. If you're not on the WhatsApp group, just to add the link to the WhatsApp group for you, and then we'll start with a session. So tonight, basically, doing a recap of study unit 6 and 7 for your assignment, and in basically looking at one of the existing mock assignments, nearly, or preps that you can do in preparation for the assignment. So we're going to go through that and see what we get out of that. Okay, so I will also, let's just make it bigger. Okay, so the first question is basically coming out of study unit 6. So the first question looks at, we need to look at different probabilities, and in a sense, some of it we will need to work out. Some of it is to say, well, we will need to nearly look at some of the definitions, because that is something that we need to look at. Also, most of them I am going to nearly try to show you on sketches how we will do it. So let's look at the first question. Which one of the following probabilities are incorrect with regard to the standard normal distribution? Okay, so let's look at A first. Want a probability that Z is bigger or equal to 0.5. So if we draw it, just resize the frame again. So if we draw it, we know that in the middle of the Z is 0. So somewhere here is 0.5. And we're looking at that area because it said it needs to be bigger than 0.5. Okay, so this already leads to nearly the question of, if I take the positive table, I will need to get this white area, then I need to say 1 minus that. So you can already see that to work out that piece in the second question, Z bigger equal to 0.5 is 1 minus Z smaller. And so you could already see that if we look at B, that is what we're actually also going to do, is we're going to say, where's the 0.5? So to get the Z bigger or equal to 0.5, we're going to say 1 minus the Z smaller or equal to 0.5. So then we're actually going to say 1 minus that blue area, which will give us the green area. Okay, so the first thing, let's do that. Let's go to the positive table. Of Z 0.5. Let's make it a bit bigger. So Z 0.5 There we have it as 0.6915. So let's just write it down. 0.6915. Okay, so if we want to work out what is the green area, it is 1 minus 0.6915. Six nine one five. I just want to work it out. So we get 0.3085. Okay, so that was in any case also the option that we got at option A. What we could also do is to say, well, and let's do another color, and it might be, I haven't read now question option 3, but is to say, let's go where again it's 0, that is 0.5, that area must be the same as the negative 0.5 because of symmetry. So if we go to the negative z table of minus 0.5, we are supposed to also get our answer that we're looking for. So negative 0.5, we also get the 0.3085. So we know that that is also a way to get it. So let's just check. Okay, so those are more z smaller than 0.5 is equal to z smaller than smaller. Okay, so that is going to be the wrong one. I'll quickly explain that. In continuous, like we're having with a standard normal deviation, you can't have a probability at a certain point. So we don't have a probability of z equal to 0.5. Okay, it's not like binomial or discrete distributions where you have at a certain point you have a probability. Because it is continuous, you basically don't have a probability if it is equal. Okay, so there is not a way that we can calculate it out because you don't have, you have it for a certain area, so a smaller van, a bigger van between 2 points, but not an exact point. So z equal to 0.5, the probability of that is 0. So you will not get it. We're not working with a discrete distribution. Discrete distribution, it's possible, but not with your continuous distributions. So let's just look at option D and E, and let's graph it out. So here they say probability of Z smaller or equal to 0.5. Sorry, Z bigger or equal to 0.5 or minus 0.5, sorry. But smaller than 0.5. So in this instance, we're looking at the areas between those 2 points. So let's just again look at it. Z bigger than 0 minus 0.5, but Z smaller than 0.5. So that component is that. So let's just see if it is then true what they're asking us. So then they say that is equal, and again for me it's easier to do it visually than to so Z smaller than 0.5. Okay, so Z smaller than 0.5 minus Z. So let's do that. Z smaller than 0.5 is that whole area, minus Z that is smaller or equal to minus 0.5. So let's put that in as well. So it is that area. So what we're looking there is that area. So again, if you have the total green area, you're taking away that blue area, you're sitting with the orange area. Okay, and then you can see those two are exactly the same. So let's just, for option D, let's just go through it one more time. We are going to do another recap session on Sunday morning, which I will also send the links out, but we will do also a previous assignment. But I think for this one, let's just quickly. So first, let's look at the first one. Z is between 2 points. The points is saying that Z must be bigger than minus 0.5 and smaller than 0.5. So we're looking at that orange component for this. Then we say, okay, but is it equal to Z that is smaller or equal to 0.5? So that green area. So that green area is that whole area. And if we take that green area and we subtract this component, we are left with the orange component. So those two are correct. Okay, so again, you can go and use the tables now to say, okay, the Z smaller or equal to 0.5, that is 0.6915, that is 0.30. So you can also go and work out the probabilities of each. But I thought this is just a nice way to represent it visually, that you can see how to look at it as well. So the same, let's just quickly look at why I originally said E was wrong. So probability that, if you look at, again, that's in the middle, 0. So they said that Z is smaller than 0.5. So Z smaller than 0.5 is this whole area, like that green component in D. But then Z smaller than minus So if we have a minus 0.5, again, it is only that area like we had in that D as well. But obviously, the purple or pink that I use cannot be the same size as the blue. So the purple component that I used is much bigger. Um, Different if the question was the probability of Z bigger or equal to 0.5 is equal to the probability of Z smaller equal to minus 5 or 0.5, sorry. So then you would have had this example where that Z is this component. So let's connect it. And this Z is that component. Okay, so that is how it would have been also if I have asked it for you in an equation. That is how it would look like. So this one is for positive, bigger or equal to 0.5. That one is for negative or smaller or equal to minus 0.5. Okay, so this is one question that they love to ask. What they also sometimes does with a question or do with a question like this is they can give it in the sense of Z, like they did with the first one, where they say Z bigger or equal to 0.5 is that. So they could use numbers that you need to go to the table for certain things as well. And I will, in Sunday's session, I will look at a question like that, where it is basically giving you more the numbers that you need to work out. So in Sunday's session, we will look at something like that. But this is, again, in assignment and in your exam, this is something that they love to ask. Okay, then they also go into the traditional ones of they give you information and you need to work out what's the probability. So again, this is out of study unit 6, where they say a random sample X is normally distributed with a mean of 85, standard deviation of 20. Calculate the probability that X is at most. Okay, let's just, as you can see, I've got this at hand. So again, please, if you can, print it or just have it with you. Again, so that it's a question's wording must not catch us out. So let's see where Z is at most. At most. Okay. So small or equal to 95 minus 85 divided by 20. So remember, again, the formula that we are using is in study is X minus mean divided by the standard deviation. We're not talking about a sample yet, so we don't bring in the sample distribution. We're only looking at at this x that is randomly distributed. Okay, so z smaller or equal to what? 95 minus 85 is 10. 10 divided by 20. Okay, so it's again 0.5. Okay, interesting. That very similar to this. So probability that z is smaller or equal to 0.5. Okay, so let's just go to the table. That's 0, again 0.5. So we need to work out what is that component. So this is cool. From the positive table, we can sorry, just give me a minute. Okay, sorry about that. Let's quickly check. 0.5. The positive table again. 0.5. So we know that area is with 0.6915. That area is the 0.6915. Okay, so I don't know if I planned it to have everything around the 0.5s for this assignment, but that is how we work it out. Let's just quickly check if I did not miss anything. It is 95, it is 85, it is 20. 95 minus 85 is 10. 10 divided by 20 is 0.5. So it might be, again, that for other, so again, remember the stats, they have 2 or 3 question papers running nearly for the assignments and going to be in the exam. So it might be that these other numbers are when it is maybe 105 and 115 or something like that. So if one look at, I just want to, for interest sake, look at Z1 and Z1.5, so 0.8413. So 0.8413. So it might be that some of you will get Z as over X as 105. So that the Z is 1, then it is going to be that one. If it is that we have a Z as 1.5, the 9332, 9332. So you can see there is nearly going to be a pattern for you guys in the different assignments. If we get to Z2, 9772, 9772, and then lastly probably Z2.5, 9938, 9938. So you guys will, it might be that for some students you needed to work out Z with a 0.5. It might be for others Z1, for others Z1.5, Z2, and Z2.5, because all of those nearly comes with that. So just again, that is how the differences in in the assignments and the exams will be. It will not be that you get a total different question. They're just going to make sure that the numbers are slightly different, and that is just to make sure that you're not communicating with one another. Um, yeah. Okay, so let's look at the next question, but please use also this table. It is really helpful in situations like this where we need to work out with words. Again, I'm happy if they give me like a question one where you know what the sign is, but when they start using the words, I just go straight to this table that I don't even need to worry about it. Okay, so let's look at question 3. Um, a local company manufactures rechargeable lights with a mean battery life of 80 hours, standard deviation of 8. What is the probability that the random selected recharge will have a life of at least? Okay, so again, I'm not even hiding it anymore. Let's use that. Um, and again, if, like I said last time, I would, if I were you guys, and I start with my assignments, I would nearly have this copied somewhere that you have it, that you don't even need to go look for it because again, it's it's not where they need to catch us out. Okay, so let's see. We need to work out the probability Z of at least, of at least, okay. At least bigger or equal to Z minus the mean divided by standard deviation. That's the probability of Z. X is 72, which is fine if, again, it is something negative, because that just means that when we sketch it out, it will be on the left-hand side, on the negative side. Um, so it seems like the probability is Z bigger or equal to, what's that, minus 8 over 8, which is actually going to be just the probability that Z must be bigger or equal to minus 1. Okay, so let's do that. So Z, so we know that is Z0, Z minus 1. So it's a probability that Z is bigger or equal to minus 1. So it's that bigger area. So we know already that is 0,5. So we need to just make sure what is the bigger area, but I now already know I'm working with a number bigger than 0.5. So if I'm working with a number bigger than 0.5, option B is not the option. Option D is not the option because my probability needs to be bigger than 0.5. So what I would do is I would go to the negative table. I would get that probability. So that will give us that p, so we can then say 1 minus that p's. So let's first do that. So Z equal to minus 1. Okay, minus, oh, yeah, minus 1.1587, which was that. Okay, so that gives us 0.8413. 0.8413, which is option C. What we could have also done, and remember, symmetry goes both ways. So it's not just for the smaller one where it is the same on this side. So if I had the minus 1 here, this area is the same as the area. So is the same as this area that I'm now going to color in with orange. So just remember, symmetry goes both ways. So that will be the same area as well. So if you have an area bigger than minus 1, it is exactly, so if you have an area that Z is bigger or equal to minus 1, it is exactly the same than the area Z is smaller or equal to 1. Okay. So just nearly out of the context that it's much easier always to see the smaller portions, but the bigger portions is exactly the same. So we could have just gone straight to the positive table of Z1 because we are also looking at this area, which you can see from the orange. So there we have just that same value of 0.8413. Okay, so again, it is looking at what is the easiest way for you nearly to answer this. I first automatically went, okay, I want to get that small area because if I get that small area and I take away or take that from the total. Sorry, I just want to take away that circle. Yeah. So yeah, so again, there is more than one way nearly to get to the answer. So again, which table is easiest for you to use? Please use that. Okay, so the first three questions was, in a sense, a bit straightforward by using the tables with the information. But then suddenly they throw in a question like this. And I think we've done one or two like this in our previous two sessions this week as well. So consider the information from the previous question. Remember, rechargeable lights have had battery life of 80 hours with a standard deviation of 8 hours. Suppose that the local company manufactures the lights for lighting warehouse. It is observed that the warehouse rejects 20% of the lights because they do not pass the minimum battery life test. Determine the minimum battery life accepted by the lighthouse warehouse. Okay, so basically we're looking where we need to get probability where Z is X minus 80 divided by 8. And that probability is equal to 0.2. Okay, so now it's suddenly a bit different. So now they tell us, well, we've got a probability. We have that 80 hours, that is the mean. We've got the standard deviation, but we now need to work out the X. But at least we give you a probability. Okay, so first, what we will need to find out is for that probability of 0.2, what is the Z value? So for that probability of 0.2, so we're looking for a probability of 0.2. So let's quickly 0.2. So this is 0.16191977. So this one is probably the closest is minus 8.4. So minus 0.84. Unfortunately, there's now not exactly, oh wait, 0.20. Yeah, so that one is the closest, 0.84. So let's see if that actually will work. So Z was minus 0.84. So let's just say it's equal to X minus 80 divided by minus, 8. So now a bit of normal algebra that we need to do. To get rid of an 8, we're going to multiply on both sides. So it is equal to minus 0.84 times 8. So minus 0.84 times 8 is equal to X minus 80. So that is equal to minus 6.72, which is equal to 80, X minus 80. So if I take the 80 across to that side, it becomes positive. So minus 6.72 plus 80 gives me 73.28. Ugh, I hate this question because if you now look at options, sure, okay, so determine the minimum battery life. So I could have easily said 73 or 74. To consider information from, suppose that the local company manufactures the lights for lighting warehouse, it is observed that the determine the minimum battery life accepted by the lighthouse warehouse. You, it will be very interesting to know what the answer is to this one, because normally I would want to say round it off to the nearest number, which is 73. But then if I test it and the battery life is 73.1, it should still be. So, oh, it will be very interesting what the actual final answer was that they accepted. And if any of you guys have done it, um, yeah, it's interesting. I don't like these ones where it's so close, because out of nature, I want to say 73 is because I round it off to the nearest hour, but because it is a bit more than 73 hours, is it not then supposed to be 74? Okay, so it will be, if anybody has done this one, please let me know what the answer is. I'm also actually going to ask the lecturer, just for interest sake on this one, how to interpret it, because I know I normally love to would have rounded it off, but is that maybe also then a catch, because it means that you're actually looking, like I always say in some of our DSC models, you can't have a product that is 0.28 volt. So would you then rather go for the 74 hours? So I hope there's not like something like this in your assignment as well, because yeah, I assume it's 73, but it would be very interesting to get an idea of when you guys did it, or even when you later on try it, if it was 73 or 74, just because it's not a rounded number at the moment. Yeah. Did any of you guys try this mock assignment? Um, I know it only was actually launched over the weekend, I think. So probably didn't have time yet to even look at the mock one. So yeah, it would be interesting to get some reactions on this, and also later on when you do it, um, and I just want to know if they've given an answer for you guys when you do it. Okay, so but very similar to one that we did in the previous two sessions, where instead of you now needing to work out the Z to get the probability, you need to use the probability to work out the Z, or to get the Z to work out the X. Okay, which is, they do love to ask one or two of these in the assignments. When it comes to the exam, it will be more the standard questions, where there might be one or two in the total exam that is something like this, and not each of the questions will be something different. So there will be something like this probably for chapter 7 as well. So that all of these was at the moment still looking at chapter 6. So I think there will be one that is probably very similar in one of the questions for chapter 7 as well. Okay, so let's go on to the next one. And let's see. I know there was a very interesting question in these that might also be very sometimes very confusing. So in this one, they tell us, okay, we've got a random sample. N observations is selected from a population where a mean of 2 to 5, standard deviation of 25. Which one of the following statements regarding the sample distribution of a mean is incorrect? According to a central limit theorem, the sampling distribution of a sample mean X can be approximated by a normal distribution as the sample size N becomes large. Sheesh. I probably would have said yes. Um, that is, yo, that's nearly, you need to look for that in the study guide or the textbook, that, or let's even just Google what this central limit theorem. That is, please don't study something like that off by heart, because it can. So let's just quickly see if I can copy this in. And and again, not all the things are going to be similar, but let's just see the principle that the distribution of sample means normally as the sample size gets larger regardless of. So that is what they're basically telling us. You can assume as the sample becomes larger that it will be correct. So yeah, so I luckily guessed that one right. But yeah, please, if what I would also for you guys in prep for more for the exam is on your in your study notes. I will just check that I include a few extra things for you in a summary document closer to the end of the year, that you have at least a pack of information that have that does contain all the theory as well, that you don't need to page through your study guide in the exam, because that is not going to work, because that just takes so much time. Okay, let's when the mean of a sampling distribution of X is 2 to 5. That is correct. If a sample size N is 20, then the standard error is. So let's just look. Standard error is worked as that. So this tells me we're already in study unit 7. So standard deviation 25 divided by this instance N of 20. So also important just to note out of this one is as N becomes bigger, so they can ask that in a theory question as well. So as N becomes bigger, that means the part that you're going to divide with is becoming bigger. That means that your standard error will become smaller. Okay, so as your n is becoming bigger, that number that you are going to divide the 25 with is becoming bigger. So that whole number, because 25 divided by 5 is 5, but as it goes bigger, 25 divided by 10 is 2.5. So you can see in this, as the size of n becomes bigger, it is true that your standard error will become smaller. Let's just see out of this if any of those ones are wrong. So 25 divided by square root of 20, I get 5,59. Okay, so that is correct. If it is square root of 30, I get 4,65. Oh, so where else did I make a mistake? Square root of 40, 3 comma, okay. 25 divided by square root of 40, 3 comma, okay. So this is where it needs to be 3,95 and not 3,26. So the one that is the error is option 3, because 25 divided by square root of 40 is 3,95 and not 3,26. Okay, so, but again, in a theory question, they could have asked you which one is incorrect as sample size increases, standard error decreases. As sample size increases, standard error increases. So they might even ask that in a theory type of question. So I just wanted to also show you guys, very important, as your sample size is increasing, your standard error is decreasing. So that's why they always would also say at some point, when your sample size is big enough, you actually are nearly working with a population, because when your standard error becomes so small that it really doesn't matter anymore. Okay, so that is nearly the point out of this one, and that is why they also included the central limit theorem, is to show this basic trend. As sample size increases, your standard error will decrease. Okay, so let's look at the next one. Yeah, this was the one that I thought is important. So just to show you guys a method that they might use to write and give you information. So luckily in this one, the lecturer also set the information. So look at this. Consider random variable with a population mean of 75 and a population standard deviation of 10. Okay, so just be aware of this notation where they say X is distributed normally, where it is with a mean and variance. Okay, so because they did not need to give us the information, they might just have given you it as a random sample variable. X is distributed normally, mean 75. Sometimes they will say they will do it 100 and not 10, and they don't give you that information. So just be very careful, and realize that they can also do it this way, where they say X is normally distributed with a mean and a standard deviation. Okay, so that tells me now that, okay, we are going to work with normal distribution. Then they give us size. So again, that tells me that we will work with the Z that is equal to X minus mean divided by the standard deviation divided by N. Okay, and in this one, they ask us nearly something that they ask in the first question. So suppose that a sample of N is 20, is selected from a population. What is the probability that the sample mean X is between 70 and 74? Okay, so between 70 and 74. So what we will need to work out is what is the Z for the 70 and what is the Z for the 74, and then we need to work out what's the probability between those two. So let's first work out what is the Z, so that we can see if we need to change this graph, if it makes sense, if it doesn't make sense. So the first one, let's take Z where X is 70 minus the mean of 75 divided by standard deviation of 10 divided by the square root of 20. Okay, so if we work that out, we get our value 70 minus 75. Ten divided by square root of 20. So if I divide those two, and just please check for me as well when you doing it, I'm getting minus 2,24. And if I look at Z74, okay, that is also going to be a minus. So that already tells me that that picture that I've drawn is wrong. And I get Z is minus 0,45. Okay, so just if you go through this, just check. We will now, in any case, see if it makes sense on the tables, what was done. Okay, so this is, so let's redraw this. Definitely wrong. Okay, so so Okay, so Z0. So there, let's say that is minus 0.45. And let's say that is minus 2.24. And we want to know that space between those two. Okay, so you can already see again that is 0.5. So this is going to be smaller than 0.5. So just by looking at that, I can say, okay, smaller than 0.5, that option D and E is not going to be. Okay, because it needs to be on this side smaller, even though it's not in proportion. At least I know to the right of the 0 mark is half of the probability. To the other side, or to the left of the 0 mark, is also the half. So that at least we can do. So what we will need to do is to say, okay, let's get the probability that Z is smaller than minus 0.45 minus 0.4. So I think it's that one. Let's just check. Yeah. So it is 0.3264. So the Z smaller is 0.3264. Just check again, 3264. Very quickly, one could have said, there it is. But that is only for the Z smaller than, and let's just quickly make room here. So that is for Z smaller than 0.45. Okay, so that is 0.3264. So what I would do is to say, okay, we've got that one, then just I did not want to do that now, as and then to get the blue area, I'll work out what is that Z smaller than minus 2.24. And if I subtract those two, because if I subtract the green with the orange, I will get the blue. So let's see, minus 2.24, 2.24, 0.0125. 0.0125. And again, typical stats. There was the one, there was the other one, but we will need to subtract the two from one another to get the blue area. So that just means that if we subtract the two, we get 0.3139. Okay, which is then option A. So it might be, again, for certain of the students, they might ask, what is this one of smaller than 0, and not between two? For some, they could have asked, what is the smaller than 70? So just again, this one is probably the most difficult one to ask a question around 2 points. So definitely one of those that is more about the one that as 2 points is more difficult. Okay. Um, so yeah, so that again was study unit 7 question. Okay, so let's go into the next question, question 7. Okay, so now suddenly they have used this, so the same numbers as in the previous one, but now they said, okay, consider the random sample with a mean of 75, standard deviation of 10. Now suppose that a sample of size 30 is selected from the population. There is a 90.99% chance that the sample mean is less than. Where is that? So they're definitely not making it easy. Is less than. Okay, so sample less than, and you need to work out what is that X. So let's put in all of this information again. So very similar to that previous question where we needed to work out the X. Now we're sitting with a 90.99. So let's just check 90.99, 90.99. Hopefully there is, with a number like that they selected like that, it should be coming out here as a real, okay, 90.99. Okay, so 1,34. So 1.34 is the 90.99. Okay, so 1.34. 1.34. So Z is 1.34. And now we're following the same process as in the previous one. We just need to now work with fractions and not just one number. So 10 divided by the square root of 50. So that is 1,83. So then if I say 1.34 times 1.83, that will be equal to X minus 75. Let's just work that out. Still not a very nice number to work with. So 2.45 is equal to X minus 75. So now 75 goes to that side. So we will plus 75 to the 2.45, which will give us then that X is equal to 77.5. 0.45. Ah, okay, so there at least is number 77.45. Sure. Okay, so there also what they brought in is if you only went for the Z, there is the Z for you to work with as well, to make you do that error. If you have not included the Z and you said 75 minus 1,83, let's see, then there's a number close to it for you. If you said 75 minus 2,45, there's also an answer for you. So just again, be very, very careful when you guys are doing this. That, and again, those other answers might be for some of the other question set, so that they keep the same answer set, but they change a bit of the numbers. So that can also happen. Okay, so this one very similar to where was it? Was it this question or no? This question. So question 4 and question 7 very similar. What you need to do, the approach. The only difference is the one in question 4 is to do with study unit 6, so it does not include a sample, where question 7 is of study unit 7. So we now look at sample distribution, so it does include a sample that you need to work with. Okay, next one. So let's look at the next one and what they ask us. In a random sample of size 49, okay, so the one thing that we haven't done yet is sample proportions, so it makes sense. Of interest is 0,7. So sample proportion. Suppose that the true population proportion is known and equal to 0,8. Calculate the standard error of a proportion and choose the correct answer from the list of options below. Okay, so I just quickly want to open our presentation of Tuesday, where we had that formula in. Those standard deviation of samples when the sample is known. Okay, so it's, and then the other one is the sample proportion. So let's just quickly copy this over so that we can just get those two. So that we quickly relook this. So sample proportion, that is supposed to be the P. And this one will be, as they say, where it is known. So where it is known, we use this formula. If it was unknown, we would use this formula and then we would use that. Okay, so again, one or two things that is important going forward also in the exam when, and we'll see it in the next study unit when we're looking at confidence intervals with the mean of known, and when we look at the mean and standard deviation, where the standard deviation is known and unknown, we will also get different formulas and different things to look at. So need to use the formula for the proportion that is known. So that's 0.8 times 1 minus 0.8. And they only want you to work out standard error divided by the sample size, which is 49. And then we take the square root of that. Okay, so 0.8 times 0.2 divided by 49, and that we take the square root of. Oh, so I'm getting an answer of 0.0571. 0.0571. Okay, so there it is. If we used, and that is just, again, if we used the 0.75, we would have gotten 0.0619. Okay, so if we worked out where it is unknown, that would have been the answer. So just be very careful. So again, for some, they might now ask the question of calculate where the true population is known or where it is unknown. So again, nearly very important, this piece that is also in your study guide, just because, again, I originally wanted to work with that when I saw it. And then when I saw this part, it's like, okay, let's just quickly see what is the difference between the two. Okay, so again, this one was one of those that they wanted to catch you out because one usually is only getting the sample proportion. So it's very seldom that you're actually getting the population proportion. Okay, so that was one where we needed to work out standard error. So again, the assumption is that there will be one that they ask us to work out but so this one is where we're going to work between two proportions again. So again, we can again change it when we see the real values, but say that is the 0.35, that is the 0.48. So what we will need to work out again, what is the probability that it is between those two. Okay, so for that, we will use, okay, and it's not taken from the previous one, unfortunately. So now we will need to say, and let's just, one doesn't use that formula so often. So let's just copy that formula in as well. I know I remember the normal distribution one is very much easier to remember. So let's just put this one in for you guys as well. So it is there at the top. So again, what we will gonna do for the proportion of 0.35, we're gonna work it out. And then for the proportion of 0.48, we're gonna work it out. So that is the two formulas that we will use. And then we will, again, like in that previous one, we will now get the two Z values. So I'm just going to keep that open for now. So we're going to get the two Z values, which I will then replot, and then we will see again what the answers will be. So let's look at 0.35 minus, they tell us 40% of advisors claim to have been a victim of click fraud. So that's minus 0.4. So on this side, it will be 0.48 minus 0.4. So at least now we can see one is going to be negative, one is going to be positive. Let's look at what the standard error is for this one. So standard error is your 0.4. So that is the population one. So 0.4 times 1 minus 0.4, which is 0.6. All of that divided by your sample size. The sample size they told us is 300. And that we will need to square root to get your standard errors. So let's just, I normally round it off to 4 decimals. So 0.0283. So it's going to be the same on this side. So let's just hope again that the calculations worked out. So Z is equal to 0.35 minus 0.4. And if we do that division, 0.05 or negative, divided by, so we on this side get minus 1.77. Sure. Okay. And on this side we get, feels like it's going to be a big number. 2.83. Okay, so this is going to be, so let's just redraw it, and then see what we get. I'm actually taking that away as well so that I've got enough space. So let's redraw it. So we're looking for the value between Z2.83 and Z minus 1.77. Okay, so again, one can nearly see on this one now we're looking for this area. So that is definitely going to be bigger than 0.5. So not that one, not that one. So let's look at what is that value. So this area in orange. So we know we can go to the negative table, minus 1,77, minus 1,77, 1,7. Let's quickly see. Okay, so minus 1,77 is 0,0384. Zero comma 0384. Look at that. So it is one of the options that they give us. Let's get the right-hand side. So this, I would now also go to the negative table because I just want that small area. And I would say negative 2,83 would give me that small area. So negative 2,83. Let's just look. 2,83 is 0,0023. 0,0023. Look at that. Also in one of your answer sets. So your final answer of a blue area will then be just to say, well, that blue area is 1 minus the green area minus the orange area will give me that blue area. Okay, so that, let's just quickly. Okay, so that is then equal to 1 minus 0,0023 minus 0,0384, which is 0,9593. Okay, which is option 1. So again, it is, this one is definitely not the easy one. It's very similar to the one that we did. Where was it? I've now missed it. We will get to it. This one where you needed to get between two of the areas. And just look at certain things. So if we set 1 minus 0,0384, there's that answer. If you set 1 minus 0,0023, there's that answer as well. So again, nearly all of the answers in this options nearly in a sense make sense. So if you were only looking at the one Z, you could have easily gotten that one. You could have easily gotten that one. You would have easily gotten the other two. So again, just be careful when you do this, that and less so in the assignment, but when you are pressured for time in the exam, one might very easily see this number, see it there and say, oh great, I've got it, and forgetting the other steps that you still need to do. Okay, let's look at the last one. So the last one now, so you could see basically what they did with this assignment is very similar or very similar questions. It's just for the different approaches. So it was, this one was the only one that was really unique. So then it was, okay, work out with a formula, work out the probability. So again, the same. Then we needed to work out the X. So that was study unit 6. Then we went into study unit 7 with a bit of the theory like the first question. Then it was a question around you get everything, but you now need to work the probability between areas. Then we got to nearly also work out the X with study unit 7. Then we went into a sample error for proportion, as we did previously a sample error as well. Then we're doing the same. We're getting two Z values. We need to get the area in between. And then the last one is when we now again need to work out the probability, or they give us the probability. So, or not. Okay, so I should have read it first. So let's read this one. Consider information from a previous question about advisors and click fraud. Once again, assume a population proportion of 40. Suppose now that the sample of 200 is taken to learn about how advisors are affected by client fraud. What is the probability that the sample proportion will be 0.4 at least? Okay, I would have said will be at least 0.4. I hope that doesn't now change outcome. So let's just, okay, so then obviously the one that they could also ask you in the assignment is, the one missing now is to work out what that proportion is by giving you a probability to work out the Z. I thought that would have been the last ones, but it's not. So that might then be something that you might get in the assignment, is basically one where sorry, I'm now jumping, but where we needed to work out the X in these previous ones. It might be that in your assignment, you will need to work out what is this sample proportion. Okay, so that is nearly the only question in this mock assignment that was not covered in the mock assignment. That's nearly the only one that was not covered, is where we actually want to work out the proportion as well. So let's just get that formula in again. So okay, so they tell us what is the probability that the sample proportion will be at least. So let's just again look at least, at least, at least, at least. Okay, there it is. So bigger or equal to, so 0.42 minus 0.4 divided by 0.4 times 0.6. Okay, so let's just quickly see again from, so 0.42 minus 0.4, that is equal to 0.02, and then the standard error of this one is 0.4 times 0.6 divided by 200, and we take the square root of it, which is, so we're going to divide by 0.0346. So we're looking for z that is bigger or equal to the 0.02 divided by, that is 0, and again, let's round it off to 2 decimals, 0.58. So we're going to look for the probability where z is bigger than 0.58. The bigger than that is going to be that area. So again, if we look at, that is 0, so on the left-hand side, there's again already half of it lying. So when we're going to work out this probability, we're going to look at the tables, but you can already say it is going to be less than 0.5. So look at that. 3 options gone. So if, again, you pressured for time in the exam, you only got to this point, you can eliminate 3 options. If you only then have to guess, you guess between 2 options. So at least that narrows it also down the number of things. So we haven't even gotten to the Z table. We just used the formula, and drawing with this, we got to eliminate 3 answers already. So again, we can do 2 things. We can go to the negative table where Z is equal to minus 0.58. That will give us the answer straight up, 0.58. So 0.281. Okay, so 0.281. Or we could have said, okay, we going to use the positive table, but then we need to say 1 minus the green area. So let's look at the positive table of 0.58. So 0.58 is 0.7190, which was one of those other answers. And if we subtract those ones, we get 0.281. Okay, so we do get the same answer, which is option D. Okay, so that is that prep assignment that you guys were shared. by the lecturer to nearly prep for assignment 2. I'm gonna look. I've got another prep assignment that was about 2 years old. So I am going to, on Sunday, we will be doing that and be going through that as well. So this one, I will again share the recording. If I get